Okay, one more time, guys, if you do me a favor and go to chapter 30, swimming pools, spas, and hot tubs. I will remind you, Aaron, my friend, that we have a swimming pool for our project. So everything that we're going to say about the swimming pool is going to apply to our project as well as the system. For the swimming pool, I have two things I want to walk you through, guys. I have, what is it, 14 slides I want to go over, as well as I do have this sheet that I would like to highlight a few things in this sheet for you guys to highlight. So do me a favor, chapter 30, go to chapter 30 as well as article 680. Everybody's there? Adam, my friend, are you guys there? Okay. Okay, thank you. You're in line? Okay, that's good. Okay, so let's go ahead and talk about a couple of things. Why do you think the Andy Sequoia book took a swimming pool and put it in a stand-alone location in Andy Sequoia book? Anybody can guess what happened when you have electricity right next to his water? Perfect. This is what we call it the perfect shock hazard. The perfect shock hazard situation when you have electricity close to a water. So that's basically why we have a special location for the swimming pool in any secret book. A couple of things we want to talk about, guys. We talks about swimming pool as wiring with regard to the human being safety. The human safety, that's the most important thing. The only reason why we specify swimming pool because you have water exists at all times for the most part, and you have electricity right next to it, and that's a big hazard. Okay, discuss the hazard of the shock. The shock hazard is the most important thing in this article, Article 680. It talks about the shock of that you can encounter from here's the I can't emphasize the shock there. And when we talk about the shock only happens if you have a faulty wiring system. You could have a swimming pool forever and you don't even follow the code and nothing will happen unless one time you have a faulty equipment and somebody is standing in a swimming pool and grab onto an object that's energized and get electrocuted. So does that make sense? It might work forever. The only time it becomes a big hazard if you have a faulty equipment. You're swimming and somebody drops something energized in the swimming pool. Could that happen on the life of a swimming pool for 50 years? Could that happen? Yes, with kids and teenagers drinking around the swimming pool and swimming and all this good stuff. So that's, I can't emphasize, the hazard always happens from a faulty wiring equipment in or on or near the swimming pool. So electrical equipment. And you see requirement, guys, for the swimming pool that we're going to talk about. This one, as I said, I have a whole list here that we're gonna talk about too. Um, and then there's so that's a swimming pool. Then we a little bit we talk about the hydromassage bathtubs and the spas and the hot tubs. They're kind of they're tied to the swimming pool. Everybody knows why a hydromassage bathtub is tied to it because there's water. So we'll talk a few things about these in case you have them. In case you have them. Okay. If you have if you have a swimming pool and it's for the swimming pool that we have, guys, what do we have? We throw one receptacle around the swimming pool for convenient doing certain things at a certain distance. We have light in the swimming pool or to lit the swimming pool. We have pumps and we have heaters, right? We might have a cover, motorized cover for a swimming pool. These are all the electrical equipment that you have to be aware of. So if you are in a swimming pool situation, the single most important one, guys, is what we call it direct contact hazard. Your direct contact hazard. So you're standing in there and you touch on an object that has been faulted. Can I emphasize the word faulted? If the if this is faulted, I can grab onto this and I'm standing right in the middle of the swimming pool. Nothing will happen until a hot touch this frame and it's not fully grounded and bonded and I grab on it and I'm standing in the swimming pool, so I'm fully grounded in the swimming pool, what's going to happen to me? This is the perfect shock. Perfect shock. The perfect shock. So be aware of that one. So that's the direct contact, grabbing into something that's energized. The indirect contact, guys, and they use the term gradient. They use the term gradient with it, gradient present. This is if you're swimming and somebody drop a radio or some object that's energized in the swimming pool. So these are the two shocks that you should be aware of, and that's why we care too much about the swimming pool and wiring them. Take this. Here's Aaron, my friend, swimming right in here, and plugging something is plugged in, toaster here, and he's going to grab his toaster from here. The toaster it has to be faulted. If the toaster is not faulted, guys, nothing will happen. When I say faulted, meaning the hot is touching the frame and it's not fully grounded. Okay? You grab it to this one, what's going to happen? You're going to have 120 volts right across here. So the current is going to go right through your heart to the ground and back, right? That's what the current is going to go. And this is what we call it the perfect shock. Perfect shock. Can you have thumbs up, Chad? Direct contact, you understand that one? Cool. Now let's talk about the other one that's not fully understood. So if somebody's to drop something in the swimming pool, could this happen with a bunch of teenagers drinking and horsing around the swimming pool? Could this somebody kick something energized? There was a lot of pictures. There was a picture of I don't know, there's so many pictures on YouTube where people having a radio like this, a stereo, right in the middle of a swimming pool, floating on bottles, plastic bottles. So that's exactly, if this is to tap, you're going to get into something called gradient, guys. So what happened is, if this is to tap, you're not touching anything. Look what happened. Then you're going to have the current coming in here, going right through you into the ground. Here's, can you guys see the zero ground? And which take you back to the source, So basically, you're going to have a voltage difference here and here of, in this case, if you look at 90, what is it, say 96, you might have, say, 50 voltage difference between them. The reason for this, the gradient, guys, he's not here, he worked for Excel. The people who work for Excel know the gradient fully. When the current goes through water or through the ground, there's impedance, right? There's impedance for the water and impedance for the ground. When it goes through the ground and the water, you're going to lose voltages. So that's why the voltage closer to the source will be 90, further away from the source will be 0. In between, there will be gradually like 90, there will be, this is 60, there will be, say, 80, 50, 60, 50, 40, 30. As close to, as you get to the ground, to the shield, it will be 0. That's what they call it, the gradient voltage. Who cares? What cares is now you have a voltage across your hands, 50 volt across your hand. If you have voltage across any object and you connect the resistor across the object, what's going to happen? Current goes right through you. When the current goes through you, you're going to be cooked. Let me tell you one thing very similar to this, guys, and very, very similar to this one in a substation. If you work for an Excel for a substation, if you're walking in a substation, high voltage, walking inside the substation, you guys have seen these substation, big substation outside, outdoor. You walk in the substation, and there's a ground fault while you are walking inside the substation. There's a lot of ways that to protect you from this, but if you, while you're walking, the current will go through the ground. When the current goes through the ground, guys, there will be voltage difference because of the impedance of the ground between foot 1 and foot 2, your 2 feet. Enough at a higher voltage to get you a voltage difference between this foot will be, say, sitting at 5,000 volts. This foot will be sitting at 2,000 volts. A difference between 5 and 2 is what? 3,000 volts. You will have 3,000 volts across your feet. Now, what happens if you have a voltage difference across two objects and you connect them? Oh, excuse me. You connect them together. You're going to have a current that going right through you, and not enough to kill you. There is a lot of stories. It's like lightning, very similar to lightning, guys. You could be standing and the lightning hit the ground and the current goes from one foot to another and you get burned. High voltage is notoriously famous with that. That's called the gradient. So that's the same thing. You're going to have a voltage difference between 2 points on that object and basically get electrocuted. So so that's why we have all these requirements for a swimming pool. Like I said, the article 680 talks a lot about swimming pool. You're going to find a few things in this article. You're going to find a swimming pool. You're going to have hydro massage bathtubs, wading pools. You're going to have a couple of others, decorative fountains, hot tubs, spas, all these locations, because they involve water. You're going to find them all in this article. Cool. We're interested at this time in the swimming pool. Now, if anybody's to guess, if you have a receptacle within the range of a swimming pool, what do you think receptacle closer to a wet location have to be on what? Anybody can guess just without knowing the swimming pool? GFCI. So that's where we can, the most important protection that you can get you out of this situation is what? GFCI. If your system is not grounded, guys, if you don't have a grounded system, and you have a GFCI protection, you will be protected, right? Because the current that comes in you, out of you, will be seen inside the GFCI, right? Inside the GFCI is the difference in the current it will trip. So if I am to guess, what do you guys guess for all the receptacles around the swimming pool? Anybody can guess? GFCI, right? Every time you have a hazard of water, you have GFCI. There's a lot of bonding and grounding that goes around the swimming pool. All the metallic objects around the swimming pool have to be bonded with number 8 copper conductor. So what they do, you're going to see a bonding table for you, very easy. Everything metallic around the swimming pool must be bonded with a copper number 8, insulated, bare, or covered. Everybody knows the difference. What's a bare conductor? No insulation. What's an insulated conductor? Fully insulated. What's the covered conductor? It has a little cover on it that's not insulated for voltage, but it's covered to protect the conductor, not to protect you, to protect the conductor from the elements. So it's a lower grade insulation. Think of it as lower grade insulation. By doing it this way, guys, it will reduce the hazard, the shock hazard. If everything is bonded and grounded, the minute that this gets fault in it, and this frame get energized, if this is grounded, what's going to happen if you bring a hot to a grounded object? What's going to happen to the circuit breaker? Immediately will trip. So imagine all these objects around the swimming pool. If you guys have to remember two things. Everything metallic around the swimming pool must be bonded together. Number one. All your receptacles around the swimming pool must be GFCI. Must be GFCI. And there's limitation on how far you can go with your receptacles. So why do we have number 8 guys conductor bond together? Put them all at the same level. So if there's a short circuit or a fault, it trips so fast before it goes through your heart. Okay, so that's what we're. Then the code guys goes into details and how to put heaters around swimming pool, indoor and outdoor. Suppose this is an indoor swimming pool and you need to put a radiant heater like this. A radiant heater. Here's a requirement for a radiant heater, like this one. You have to put it. You can't put it closer than 12 feet because of the hazard of electrocution. You can't also put it closer than 5 feet from the inside of the building. Can you guys see that? Now you don't have to memorize this unless you want to sit for a German exam. Nowhere to find him in an NEC code book. It has to be permanently installed. Must be permanently wired, installed. Must be grounded, isolated. Fastened in place, securely fastened in place. So now if you're having a radiant heater like this, now if you have a unit heater has a fan in it, right? A heating element and a fan. It could be a heating element, by the way, or it could be a gas. A radiant heater could be also the heating element is a gas and you're throwing just a fan through it. Does that make sense? The heating element could be gas and you're throwing in. If you have that one, here's the limitation. Your limitation is only 5 feet. No limitation in how far, because all what you're doing is just blowing air through a heating coil, which could be most likely gas, coming from gas. You're burning gas and throwing air through this coil. So they allow you 5 feet. So there's a lot of requirement for this one, guys. So again, if they're within 20 feet of the area, so a lot of stuff you have to put them at 12 feet. Now if you go further away than 20 feet, you can put them anywhere you want. Can you see the limit here? 20 feet. You want to put them. If I put my heater, I can put it right here, as long as it's not within 20 feet, more than 20 feet from a swimming pool. Any comments about this? This talk about a lot of requirement like this, guys. A lot of requirement, and these are not water heaters. Water heaters, they heat the water completely differently, guys. For water heaters, if you have a water heater, this is heating elements for heating the space. Any comments, any questions about these requirements? So that's your requirement. This one is really interesting picture. Wet niche. Jenny, my friend, they have a wet niche luminaire. You guys have been in a lot of swimming pools. They have lights in the floor and in the walls of a swimming pool. These lights typically are low voltage lights. The way they do them they have a requirement. If you read through this one, it's hard to see it. You can see on yours. You have to use rigid or intermediate or PVC conduit to wire it. You have to have an isolation transformer that feeds it. You have to have a grounding, a continuous number 12 grounding conductor that goes all the way. Can you guys see that? See that grounding conductor number 12 that goes all the way to the light? That's number 12 grounding conductor that goes all the way. You have an isolating transformer. You have a box. If this light is fed from a higher voltage, you have to put it in a GFCI. So the circuit breaker have to be GFCI. In 2011, Aaron, they came up with low voltage contact limit. They call it low voltage contact limit. Low voltage contact limit, guys, is a bunch of lights that run at lower than 120 volt. Bunch of lights. One of them is 30 volt DC, 15 volt AC, and I think, I can't remember, there's 24. There's a bunch of these voltages that they can run them at, and they call them low voltage contact limits. The common denominator between low voltage contact limits is if you run them, you don't need GFCI. Why? Because the voltage is low and the energy is low, so the electrocution, you don't have to put it in a GFCI. Okay, so that will give you guys the wiring requirement for a wet niche luminaire. There are two types of luminaires. There's dry niche luminaire and wet niche luminaire. It talks about basically the bulb itself is completely immersed in the air and in the water if it's wet niche, or it's dry, you know. If it's dry, so you have to have another. If it's dry, you have to have another way of getting into the bulb, right, from the other side. Either way, you have to have a grounding number 12 conductor copper going to the fixture, isolating transformer. You have to put in a GFCI. Your ground has to go all the way to the panel, to the source. Any comments, any question? You have to use PVC. Most of the time we use PVC. Rigid if you have, or PVC schedule 80 if you have physical damage. This is mostly for installation, but for you as a project manager, it's really nice to know. Any comments, guys? Any questions about that before I move? Okay. All right. The second one is bonding. This is the picture that I want you, Kerry, my friend, to grab and put in your projects that's due next week. Everything. This is very simple. Very simple. All what you have to remember is one little thing. Very simple. You have to have number 8 CU cover conductor, and grab everything metallic around the swimming pool and tie it to it. That's it. This is the grid, the concrete rebars for the swimming pool. And you're going to tie everything to the concrete rebar of the swimming pool. You can see all the ins and outs of the water coming in. The ladder, the diving board, everything around the swimming pool have to be bonded. The fence, look at the fence. If you have anything, heaters, all these equipment have to be bonded with number 8. Anybody can tell why they bonded with number 8? If I'm in a swimming pool and this is bonded to number 8, and this thing got hot because the hot conductor touched the frame, and this frame is bonded, what's going to happen to the circuit breaker? It's going to trip. Safety. Because remember, the fence is not carrying current, right? So if the fence get energized, the circuit breaker might not trip until somebody somebody comes and grab on this fence and touch the water, and now you get electrocuted. That's why they want to bond the fence, right? All these objects must be bonded with number 8. Can I have a thumbs up, Chad? We got it? Okay. Here's what I need you to do, Joe, my friend. I gave you this one in a Word document. I want you to load this one into your project as a picture, as is. And when we load it, we crop the bottom of it, and that will be our bonding and grounding detail. Remember the bonding and grounding detail for our swimming pool? You can't find a better picture than this for bonding and grounding. As a master electrician, Jamie, I always say, if in doubt, if there's another object that's not listed here and you're in doubt, what do? Bond it. Don't split hair. There's a tiny little thing here, I'm not sure we have to bond it. Bond it. Remember, you are designing a system and installing a system for 50 years for people to maintain it, enjoy it safely. So would you be cheap for a number 8 conductor not to bond certain things? No. Any comments, any questions, guys? The ray bars, if you're building, so these ray bars, guys, 12 by 12, they make they bond the whole bottom of the swimming pool as well as the belly of the swimming pool. So if this is the swimming pool belly, all this will be, there will be array bars also bonded here, and or copper conductor number 8. They make a grid. A grid. The whole swimming pool is all bonded with a grid. And that grid, bottom and sides, everything else will be bonded to it. Can you have thumbs up, Chad? We understand that? Number 8? Okay. Really not rocket science to it. I don't know if you guys heard about the young girl in Minnesota. She lost her private one time because she got stuck. Anybody heard about that story? And she died. And eventually she died. And I think there's a law named after her. Anybody remember that? I can't remember what the name of the law, but there was a law. This is exactly what trapped on the water. You know, if you go to the sucking, when they have a pump is sucking, there's so much power these pumps are sucking. A kid or an adult could be stuck from the amount of power they suck the water. You could be stuck in, and that girl, poor girl, did, you know, she died. All her private stuff got sucked up, and she died because of that. Because of that, they have a shut-off switch, shut-off control switch that shuts down the pump as the pump circulating. In an emergency, somebody gets stuck there, and you see that they can't get out because of the, you know, they're stuck with the pulley. You have to go there and push the button, mushroom head button, and it will shut down the pump. That mushroom head button, 5 feet away, not less than 5 feet away. Looks like a mushroom head button like this. You see everything, somebody is stuck right there, and you push that button and it damages the pump. Okay, so as I said, it was a year ago when that poor kid died. Yeah, a year ago. So that's basically what they're saying here: the mushroom head button to shut down the pump upon the existence of a trapping. The rest of these guys are FYI only. A lot of UL listing for all the equipment, from the lights into the grounding and bonding and the swimming pool and the junction boxes that goes into the swimming pool. So that's basically what disregard. That's basically what I want to show you. The other part, guys, I would like to go over with you is the list. Let me go here. If you do me a favor, grab the, I don't know if I can do this one. Grab the, can you do me a favor, guys? If you grab, how am I gonna do this one? And okay, so let's do this. Take this out and turn the light on. How about that? Okay, you guys grab this sheet, please. Grab this sheet, and this sheet. Everybody has this sheet. Basically, this sheet really summarizes the whole bonding and grounding and everything that you need to know about the swimming pool. So I'm going to start from right. I highlighted a few things for you. Everybody has this sheet. This is a swimming pool detail sheet. Comes with a book that you guys have. Cool. Take a few seconds just to grab it. So if you guys
She got sucked, like, she like sat down, kind of.
Yeah,
Sat
sucked her
on
intestines
and basically
too.
sucked everything up.
Like really full belly button.
Yeah, just
Sucked everything in the skin.
really?
Oh,
She died
yeah,
about
they-
2 years later. That was it.
it was
It
sad.
was at a hotel. Yeah.
Was it at the, like, the bottom of the pool?
Yeah, it's the main drain.
I don't really ever feel like I was suction at all. I guess if you,
Well, it was a faulty,
if you cover it, was a faulty deal.
but if you cover it completely.
Yeah.
Yeah, because it didn't have a grate or anything on it either, did it?
No.
That's the reason why.
No.
At a hotel swimming pool, they would have put a big grate on that. Wow.
No, that was a bad situation. I thought I had this guy's blueprint. Here you go.
she's only like 8 or 9.
Yeah, that was sad.
Are these for all types of swimming pools or just for like the big hotels or apartment complexes?
The bigger swimming pool. Here you go.
But
Actually-
most states, I know Minnesota requires it at swimming pools.
Actually, I don't need this because I have it on my screen here. Okay, let's do it. If you guys, I have it on my screen. If you guys, everybody's looking at this one, guys. Can I have thumbs up, Chad? Everybody's looking at this. Okay, let's start from the upper left corner. Upper left corner. Can you guys see that? No niche luminaires. It talks about no niche luminaires. And it talks about for installation above, here's what you need to do. Look at this. If operating at more than 15 volt, now change this 15 volt, they change it guys into low voltage contact limits. You have to put them on a GFCI. So if it's higher than the low voltage contact limit, which 15 volt, 30 volt, 24 volt or something, you need it to be a GFCI receptacle. Must have factory installation, and they have attached flexible cord with 12 feet because knowing that you need to be able to pull them up and maintain them, and talks about the cord that comes with them. So that's basically the no-niche luminaire requirement. I'm going to flip, and you guys will talk about it in a second here. I'm going to flip the right, and the articles that talks about them is right there too. Luminaires installed 5 feet or higher in this shaded area. Can you guys see it? It talks about the shaded area. First of all, here's a big picture. Here's your swimming pool here, and look at this luminaire. This luminaire right here, this is within 5 feet. Can you guys see the 5 feet here? Everybody can see the 5 feet. This luminaire in the 5 feet. If you put it within 5 feet, what requirement do you need to do for luminaires? And there's a lot of information here, guys. Number one, the pool shall have at least one. Here's the requirement for this one. It has for existing luminaires may be located only existing 5 feet from the inside of the pool. If it's at least 5 feet above the maximum water level, only for existing. This one for existing. Normal, you have to move them away 5 feet, put them in this area, and they have to be 5 feet away from the swimming pool, and they have to be GFCI unless they are low voltage contact limit. Can you guys see that one? So there's 5 feet away from a swimming pool, kind of a sacred cow. You don't put anything closer than 5 feet away from a swimming pool. So that's for the light. I'm going to bring the receptacle, guys. Your receptacle, can you guys see your receptacle right here? Your receptacle here, pool shall have at least one receptacle. Do you guys remember what I told you that you have to have at least one receptacle? 120, 15 or 20 amp. The receptacle cannot be installed 6 feet from swimming pool or further than 20 feet. And it has to be GFCI. Can you have a thumbs up, Chad? One receptacle, not closer than 6, not further than 20 feet, GFCI. That's requirement for your receptacle. Inside, okay, shall be 15 receptacles. So that's your receptacle. If you guys can see right in here. Luminaire installed in this shaded area. You have to be a lot of GFCI for luminaires. Let's go into this receptacle here. This particular receptacle, special receptacle. Receptacle that provide power for the water pumps, blah, 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 shall be located not less than 6 feet from the inside of the swimming pool. Receptacle shall be single or locking and GFCI. If you have a receptacle, that's like this is for storable receptacles and storable pumps. You have a receptacle, you're plugging the pump into it. It has to be, can't be less than, closer than 6 feet. That's 6 feet for receptacle sacred cow. And it has to be GFCI. If it's 120 or 240, 15 and 20 amps, it have to be GFCI. So there's a lot of stuff, guys, about this one. Moving into this area, you can see equipment grounding conductor is number 12 minimum for the wet niche and luminaires that we talked about. If you look at the motor here, look at that one, that tying to this motor. Conduit must be rigid to tie to this. This is double insulated pump. If you have double insulated pump, you still have to provide a number 8 conductor. Can you guys see the number 8 conductor right here for grounding? So there's few things, and you can use PVC, MC cables, so forth. If you have a pump, this is where I want you to, in your case, what's the voltage of the pump that we're running for our project? Anybody remember the voltage? 240. If you have a swimming pool pump that run at 120 through 240, so that will cover 120, 28, and 240 voltages. single phase. And if the pump is powered with a 15 amp or 20 amp circuit, this pump have to be GFCI protected. Exactly what you guys are going to have. It's going to be a GFCI circuit breaker protecting it. Has to be GFCI. So what happens if it's hardwired? What do you do if it's hardwired? You put a GFCI one. Circuit breaker, 2-pole GFCI circuit breaker. Can I have thumbs up, Chad? For our swimming pool, since it's going to be 240, we're going to have a 2-pole GFCI circuit breaker protecting this circuit. Because most likely it's going to be less than 20 amps or less. Can you guys highlight this particular one here? Because that applies directly to our project. So, and I'm picking a few things, guys, picking and choosing here. Now, we don't have light. Now, when you put your light, for your lights, if you want to put them, that's what I was telling you, Jeff, the other day. If you want to put your light, when you put your poles, pole-mounted light, make sure they're 5 feet away from the swimming pool, around the swimming pool, at least 5 feet away. Cool? So you have to put them 5 feet away, and we'll put them in GFCI, like we said here. They're going to be in GFCI 5 feet away. Now, if you want to put swimming pool right at the top of the light, right at the top of the swimming pool, what's the requirement? Look at this. You can put 12 feet, minimum 12 feet. So you have to go 12 feet from the water level and put your receptacle. There's some exception for 7 feet 6 inches. Shall be listed. If you guys can see that requirement right here, it says luminaires and ceiling suspended pedal fans. You can put them up to 7.6. Can you guys see that magic word here? What's that magic word? You have to GFCI them. Can you guys see that little here? GFCI. So the rule is, if you put light above the swimming pool, what's the rule there? Not closer than 12 feet. But you have an indoor swimming pool, the ceiling is lower than 12 feet. So what do you need to do? Then you have to have a listed fixture for wet location, and you GFCI the circuit. And you can't put it closer than what? No matter what you do, you can't put it closer than 7.6. Can I have thumbs up, Chad? We understand how to put it. Not like we're not putting lights above the swimming pool, guys, in our case. So our swimming pool, we're going to end up putting basically pole-mounted lights. We move our poles 5 feet away from the swimming pool, and we make our poles maybe 8 foot high, and we GFCI that circuit. That will get you the requirement. GFCI that circuit. Can I have thumbs up, Chad? Put them at 8-foot pole, GFCI the circuit, and put them further away, 5 feet, and you're good to go. So that's your light for GFCI. Here's your wet niche luminaire and dry niche luminaire that we talked about, and the grounding. You need to have an isolating transformer. Do you guys remember we talked about this one with a number 12 conductor coming to it with PVC conduit? You have to, so that's for this. Let's talk about power lines over swimming pool. They give you clearances. What, can I bring a power line over the swimming pool? Right at the top of the swimming pool? No problem. If your voltage, look at that, insulated conductors, up to 750, here's the clearances, 222.5 clearances in any direction away from the edge of the swimming pool, and at least this amount clearances above diving plate. Communication, if you have communication cable like phone, can you guys see the number that you have to maintain? 10 feet. So anyway, and all these guys becomes a big deal. So overhead, above, diving, blah, 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 towers, platforms, areas, decks exceeding 10 feet from inside walls of the pool shall have not less than, so you can't put them right above the swimming pool, and you have to maintain a clearances. Look at the clearances you have to maintain them. 10 feet away from the swimming pool, and you have to maintain all these clearances for them. So overhead wiring above diving, all these areas, platform, plug over, extending horizontally 10 feet from the inside wall of the pool shall have not less than the following clearances. So you have all these clearances, 22, 14, and 10. Any comments, guys, about these? The rule, guys, is you don't bring power lines right above the swimming pool. So in our case, now do you understand, Zach, why I told you guys our power lines coming to the building are coming from where? Did you see what we did there? Anybody notice that for underground, we trench it? Because we don't want to get into getting all these 22 clearances above the swimming pool and have higher poles and so forth. Okay, so that's a few things. A couple of things, guys, about swimming pool here. Um, Maintenance disconnect. Now for the swimming pool, electrically operated pool covers. Your covers, if you have a cover, anybody have seen a cover that covers a swimming pool, electrically operated cover, and all associated shall be at least 5 feet from, you can't bring it closer than 5 feet. They have to be on a GFCI circuit, that motor that runs on it. And you have to have a disconnect. Can you guys see the disconnect, the controller for the cover, and on a GFCI circuit? And not closer than 5 feet. So you can go 5 feet with your disconnect, and that motor that drives the cover have to be in what? GFCI circuit. GFCI circuit. Any comments, guys? Any questions about these? And I'm picking and choosing here certain things, picking and choosing certain things. Okay, cordon plug, things that switches. This is interesting. Switches. How about switch for light? Look at that. Switches must be located at least how far? 5 feet from the inside wall of the swimming pool. Low voltage switches are listed for use within the 5 feet. Now we have a low voltage switch. You can put it within the 5 feet. High voltage switches 5 feet. Any comments? Any questions, guys, about that? Any comments? Any questions? So this will summarize basically the whole requirement for you. To recoup what we've done, you need at least one receptacle, guys, within, for a swimming pool, not closer than 6 feet, not further than 20 feet GFCI. Can you have check, Chad, for that one? Your lights, move your lights away 5 feet from the swimming pool and GFCI them. If you put them GFCI them. Your pump, if it's 20 amp, 120 and 240, which is in our case it will be, you're going to GFCI your pump, right? So what do? You put a 2-pole GFCI circuit breaker, feed it to the pump. You have to have a disconnect for the pump, not closer than 5 feet from the inside of the pump. So make sure you put it not closer than 5 feet to disconnect. You disconnect the pump, and the pump will be GFCI'd if it's 120 or 240 or 208, 15 or 20 amp circuit, right? Power lines, we talked about the power lines and the top. Switches, if I have a switch, a high voltage switch, how far you have to move horizontal? 5 feet. So these are a few things, guys, you need to do. But we talked about bonding too. When you bonding the ground here, there's a few things about bonding I'd like to mention here. All this, guys, is bonded together. What they do is they also put a number 8 conductor around the whole swimming pool. This is number 8. So as you walk, here's the perimeter of the swimming pool. As I walk around the swimming pool, guys, I'm walking on a grounded concrete, or it doesn't have to be concrete, or gravel. The ground up to 3 feet, they have a number 8 conductor around the swimming pool. Just number 1, number 8, around the whole swimming pool, within 3 feet of the inside of the swimming pool. Why? Because if I'm walking around the swimming pool naked, or what? They don't want you guys, they want you to be walking on the same potential. There's no potential between leg 1 and leg 2. So that's what they do around the swimming pool. And I want to remind you, everything else around the swimming pool have to be bonded to the swimming pool too with number 8. Any comments, any questions, guys? Any comments, any questions?
So would you bond to that number 8?
Yes.
Around there?
Everything is bonded to number 8. Yeah.
The rebar is going to be.
Rebar. You will have rebars over here. All these are tied and bonded together. That's how they do them. If it's concrete, if this is concrete, so all these will be bonded together, obviously through the rebar. And then anything mechanical, where's the diving? Do I have the diving board here? Will be bonded to it. Anything? Do I see anything else in that one? The motor here will be bonded to it. The lighting fixture, guys, will be bonded through the grounded conductor number 8, number 12. What else? Do I have a heating element? See if I have a heater here bonded to it with number 8. Any question, guys, about the swimming pool? So for our project, Joe, all what you need to do, 1 GFCI receptacle, like we said yesterday, not closer than 6 feet, GFCI. The light, pole mounted lights 5 feet away from the swimming pool, GFCI them, throw them in GFCI. The pump itself is going to be on the 20 amp circuit, GFCI that pump. The water heaters, the heater does not have to be on GFCI because it's heating the water somewhere else. But you have to have a disconnect for the pump too. You disconnect for the pump. Any question, guys? Any comments? Any questions? Any comments? So that's what I wanted to share with you in terms of the swimming pool. Okay, so I don't know if we forgot something.
And the one receptacle you need can't be more than 6 feet above, or 6.5 feet above ground.
Did it say that? I can't remember the height. Typically we don't put it, but I can't remember if there's a height in the receptacle. Here's my receptacle. Did it say receptacle shall be located at least 6 feet from the inside wall of the pool? Receptacles, I can't recall. Inside
Shall not be more than 6 feet 6 inches, 2 meters above the pool platform.
Other receptacles shall be located at least 6 feet from the inside. We're looking here. Receptacles within 20 feet wall.
Right there.
The first one. Okay, let me just let's come. Okay, pool shall have at least at least 6 feet, but not more than 20 feet. And and located not more than 6 feet above the platform. Okay, you're right, absolutely. So typically we don't put them more than that, but it's there too. Otherwise it would be impossible to reach it too. Yep. So not closer than 6 feet, not further than 6 feet high, and it has to be GFCI. Any comments? Any questions? Like everything else, Kerry, in the code, my friend. When you guys, this is just an introduction. When you have a project that has a swimming pool in it, and you are the project manager, Joe, well, you know what you need to do? If I were you, and that's my project, I would go review this one from A to Z as a project manager. Does it make sense, guys? Okay, so that's all what I have for this particular one about the swimming pool. Okay, can we have guys 5 minutes, and I'm going to flip to a different topic.